Now that we are moving towards the closure of routing algorithms and the network layer, it is about time to look at some of the problems that shall help us to substantiate and reinforce our concepts. For that, in this module, we should look at the problem sets associated with routing as a Dijkstra's algorithm problem. We'd look at some of the entries of a topology and determine how we can find the shortest paths. Then we'd look at the policy-based routing protocol, specifically the border gateway protocol. And we'd look at the behavior and operation of inter-autonomous system routing protocols. The authors in the top-down approach have emphasized on the practical protocol issues, and that is very relevant to the protocol design that you shall subsequently do in simulation of various routing scenarios. Let's look at the topology for shortest path finding algorithm first. Here you can see that, as always, the routers, also called the nodes, are represented with alphabets starting from X, Z, and so forth. Their connectivity is shown to you, and their link weights are also shown here. Now your job is to determine the shortest path from X to all the network nodes using the Dijkstra's algorithm. Remember that you would start with an empty set for X, and you'll start to include the nearest neighbors first with their link costs. The next important and pertinent problem set that we have to deal with is for the border gateway protocol and inter and intra-autonomous system connectivity. The topology that is relevant and of our interest now is shown to you here. We have 4 autonomous systems, each with their own respective network topology. These are connected as shown here. What we are interested to know is the behavior of inter and intra-autonomous system protocols to discover the destinations. Depending upon which destination to discover, we'd have to relate it to either intra or inter-autonomous system protocol. Let's understand the topology first. Consider the network that you have just seen. Suppose autonomous system 3 and autonomous system 2 are running open shortest path first for their intra-autonomous system routing protocols. If autonomous system 1 and autonomous system 4 run routing information protocol as intra-autonomous system routing protocols, and also suppose that exterior BGP and interior BGP are used for inter-autonomous system routing protocols. If you would have noticed, there's no initial link between autonomous system 2 and autonomous system 4 as shown through a dotted line. Now, given this topology, it would be interesting to explore if router 3C learns about prefix X, which routing protocol does it exactly use? Does it use OSPF, RIP, E, or IBGP? Router 3A learns about the same destination X from which routing protocol? Router 1C uses which protocol, and router 1D uses which protocol? If you are able to figure out this, you are in a good position to simulate this and similar scenarios in Omnet++. You can try Castalia and Mixim with INET framework for that.